So what we're going to discuss now is basically troubleshooting and maintenance, things that you'll have to pay attention to when you're operating the system. A little bit of tips and tricks, right? So for BridgeWorks, there's not a whole lot of things that generally are found to go wrong, but sometimes you'll have things where like you've lost communication with the hardware, for example. And the way to resolve that is you come up to the file menu and you click on rescan for bridge. And what this does, of course, it just rescans, locates the bridge, and then re-downloads the coefficients. It basically resets the system and re-initializes the communication. You see this menu or window will pop up for a few seconds later, and then it'll just disappear. Other types of routine maintenance that you'll find in BridgeWorks is something called a scanner exercise. Now this is basically a checkbox window where you can start the process, and what it does is it basically just actuates all the relays inside the scanners. And the thing about the relays is they are mechanical. So if they've been left to rest for a very long period of time, they should be exercised just to keep them loose, free, and keep your contacts clean. And so this is a utility to help do that, because it just that run for about 5 or 6 iterations, maybe once a month, and away you go. Also in BridgeWorks, there are other plugins, which we'll discuss at length later, but there is verification for the 6622AF itself, which is the bridge. And there is also a quick check, which you can run about maybe once a month or so, just to make sure that things seem to work well in terms of high ohms, normal ohms, and low ohms operation in the bridge. And there's also a utility for checking the calibration accuracy and quality of the range extender as well. And again, that will be discussed a little bit further in the training video when we get directly into those plugins. Also, with BridgeWorks, when measurements are running, if there is an error in the measurement from the bridge, a measurement error, which we'll discuss measurement errors in a moment, the measurement error itself will be suppressed, meaning the window will not pop up. It will not stop all your measurements. It'll just put a little note inside the test overview file and let it run along so they can carry the rest of the measurements out, and then you can review that and see why that test had created an error in the first place at the end of the process. And that will at least let the rest of your measurements carry on. And that's essentially it for BridgeWorks. Throughout the software package, there's also a couple different configuration windows to help you look at the bridge and look at the system and its overall setup, and we'll just cover those real quickly as well. And here we have, in the maintenance menu, you have system setup. And under system setup, you can see here you've got your different scanners and your bridge that are connected in a GPIB address. And from this list, you should make sure that you actually have the right range extender selected, so that the system will control the range extender over here. And of course, this is a 6623A300 range extender. So in the system that you have, it has to be of course, the model that corresponds to the one that you are using. And lastly, there's something called coefficients. You can see it's grayed out here. It's typically under administrator control, which you can get to in the administrative options. I have it locked out at this point in time. Well, open it up. And you have to use some caution when you're in here, because this is actually the calibration coefficients of your bridge. And I'll have a listing here of all the coefficients. And of course, the example here shows that they're all zeros because this is an uncalibrated system used for the training video. However, you should see data in there. It's very important not to modify this data in here, but to ensure that the data matches the corresponding reports that come with the system. Now, outside of BridgeWorks, there is one other area in which we have to just make sure we want to know that the parameters and everything is set up correctly, and that's actually the GPIB interface itself. Particular settings within them that you want to make sure that are loaded correctly in your driver for your system. Now, you may actually have to have administrative privileges on the system under a Windows 7 environment to actually make any changes to these settings. But I will show you an example of how this is done and what settings you have to look out for and make sure that it is correct. So to do this, you would open up Measurement Automation Explorer. This is supplied by the National Instruments driver for the USB interface. You can see it takes a few seconds to load here. Once it pops in, you just check your devices and interfaces. You see that your GPIB device is loaded here. And the settings are set right here. And you can see right now that I do not have the ability to make any of the changes here because I'm not logged in as the administrator. The important settings you are looking for is this auto polling checkbox here should not be selected, and by default it usually is. So you want to make sure that is not, and if it is checked in, make sure you log in as administrator so you can deselect it. And the other thing is the bus timing down here at the bottom. This is set for 2 microseconds, and by default it's usually 500 nanoseconds, which is actually a little bit too fast for the passive electronics inside the 6664 scanners. And so you want to make sure the bus timing is set to 2 microseconds, which corresponds to the speed in which they communicate. And essentially that is about it for the settings in here. Once that's set properly like this, then you just close the window and you know everything's okay. So now we're going to basically discuss some of the things you'll run into when you're making measurements if we hook up things wrong or you make a couple mistakes here and there. Essentially this is a troubleshooting guide and basically a diagnosis guide for measurements if you find you're not getting the results you're expecting and that sort of thing. So off the start, we're going to begin with measurement errors that come present on the bridge whenever you're setting up tests or executing tests. So to begin with, if you were to enter a test and you're going into, so we edit ohms and normal ohms, we're here at the test setup window. Now if we don't set up any of these parameters here or we miss even just one of them, basically if you hit OK to set this test, what's going to happen is it's going to tell you reversal rate's too low, you need to be at 4 seconds or greater, and you need previous to clear the screen, RS value, because you need to set RS value. These are all errors. If you did any one of these things, they'd come up and they'd tell you you did it wrong. So again, test value not set, and max value, of course, the protection value for your RS resistor, your standard safety value, would come up as an error. So if you miss any one of those parameters in the test setup, it will basically kick you back and tell you that you've made these mistakes and not allow the test to execute. And so that's one of the things you'll run into along the way. Another one that you might run into is if you did set up an appropriate test. So we'll do a 10 ohm and a 100 ohm. First rate 20, 3.16, and 100. Okay, so there's a clean test I would accept. Previous and previous, get ready to start now. Up here I've got my 10 ohm and my 100 ohm set. So when I'm going to make this measurement, I'll start the measurement, clear the buffer. Now what happens if I actually disconnect the resistor? So basically it'll come up with a measurement error. And so what you see here is a servo rail. The servo rail error is essentially the bridge was trying to make a balance, couldn't make sense of the values that were there. So you get previous to clear the value, and essentially you have to diagnose what's wrong, right? And the servo rail usually, whenever that error does come up, it usually means you have a poor connection or something is wrong in the actual configuration. So first thing you would do is take a look at the scanners, for example, and say, okay, well, are the 2 channels I expect on? And that can be told by looking at the indicators here. Secondly, when you determine whether or not these values are connected, you would want to check the other end of the cable. So if you're connected to any of these free channels, you would go and check to make sure that these wires are not broken or pinched too hard and that they're not closed on the insulation, or if they're actually a bit loose. That would be unacceptable, right? So you'd want to make sure that was tightened down appropriately. Earlier we were discussing some of the setups as well for measurement guard. If you find that you have the guard disconnected, you'll end up with noisy measurements, and the results may even cause the servo to rail as well in high ohms. So in the back of the rack, there are a number of connections in the back for how to connect all the scanners to all your resistance standards and directly to the bridge, as well as the range extender connection in the back. You can see that this cable here is similar to that goes to the back of the range extender, and this cable here, you want to make sure its connection is secure as well, and it can be twisted on and twisted off. So that's it's a very secure connection, and it'll actually lock. You want to make sure, of course, your guards are all connected. There's a guard here, and then there's a guard up here, and consequently you see that all of these come across here to this guard bar, and all the green wires will be connected here. And so you just want to make sure these are all secure. Do not touch these during measurement. Up to 100 volts can be present on this copper rail while measurements are taking place. So you want to check this, of course, while the measurements are not operating. Other important things to check for is in the back of all of the jacks that are in the back of the bridge. You can see one here as an example. these wires here, they can become loose. And to check that, you can go to the back of these. You see that there, and there's set screws inside. And these set screws can come a little bit loose, and if they're loose, they'll cause intermittent measurements, noisier measurements. So you just want to use a small blade screwdriver and just make sure that they're snug. And when you know that they're snug, tight enough to be tight, bear in mind this is copper, so if you tighten it too much, you can actually crimp it and pinch it as well too. So just a reasonable snug fit, and just once that's done, place it back in. You can actually do that just straight in the rack. You don't actually have to pull them out. You can just reach in across every one of the connections, and this is how I usually do it. Just make sure they're all tightened correctly. All the cables themselves, you want to be sure that the appropriate jacks are plugged into the appropriate resistor. For example, here, these are all labeled 66, 34, 10 meg. So this is going to the 10 meg resistor, P1, C1, right? So this is going into P1, C1 here, inside the resistance element. You want to check that because these are routinely switched out during the calibration cycle. And so another thing is sometimes they can be set off. Some people make a mistake and they'll plug it in and one jack is not in, the top one is. So just make sure both jacks are plugged in all the way. And you'll typically work these things out as soon as you bring a new standard back in and actually run a verification process anyway. But nonetheless, you want to check these out. And of course, the back of the bridge itself has the same connections, run up through all the scanners, and then of course all these individual wires here. And that's essentially all the things you want to look at in the back of the rack to ensure that your measurement quality and you don't have any intermittent problems. Other things to look for when you're running your tests, again, is if you have for the range extender as an example, you want to make sure that your C's are connected to your range extender, and that C1 corresponds to C1, and C2 corresponds to C2, P1 corresponds to P1, and P2 corresponds to P2. Sounds simple, but with the range extender, because it is connected in two different places, one to the actual wires going into the bridge, and the other one is the actual set of wires going to the range extender, this commonly gets confused amongst their users. So we want to make sure that that is recognized and working. Another thing that sounds very simple is to actually ensure that the power is on. A lot of times the range extender people leave that off while they're not operating it. So you want to make sure that's on and warmed up properly for at least 1 hour before actual use. And lastly, this connection cable here on the back of the range extender, this goes to the back of the bridge, and you want to just make sure that that's actually making a secure connection. It should be very tight to pull, and you shouldn't be able to pull it off. It's actually got a screw latch to hold it in place. And so those are some of the common wiring errors you'll find. The other thing you'll want to make sure of that is if you are making these connections, pay attention to the fact that you don't have dirty contacts or a lot of oil or grease on top of especially high value resistors, because they're susceptible to leakage for these types of measurements. As well with the lower value resistances, you want to make sure that your cable connections are secure and that you are making a true 4-wire connection, because any type of miswiring here or poor connections, especially on the current terminals, can cause a lot of noise in your measurements as well. When you connect up 2-wire devices, which will show what the decking box, you definitely want to make sure that you're joining here right at the junction, and not trying to use, some people like to use different shorting bars and other tricks to put the P's and C's together on the terminals, and that tends to create intermittent or relatively sketchy connections, which will eventually cause you measurement errors and noise as well. So with the system, there are several different things you can use to check the entire system as a whole. One, of course, I mentioned is the verification utility. There's actually a document that was provided with the system in the reference guide on how it's called the acceptance test plan. And this document itself actually goes through all of the functions and checks you want to make to determine that the entire system is in full operational order, which of course includes the verification of the bridge, the range extender, and actually confirms all the connections in the SR1010 adapter over here and the remaining existing channels. That function can be found and executed. It takes pretty much an entire working day to run, and the verification process will run overnight and give you the results in the morning. And this will confirm the system's operation to its full rated specifications. And as a final note, when you're making measurements, we are measuring down to less than 1 part per million for accuracy and stability. So when you're dealing with measurements of this quality, generally speaking, you have to pay attention to a lot of the caveats that can govern the measurement. For example, EMI radiation. So the resistors themselves, you should not have a problem with the ones in the rack as they are shielded and temperature stabilized. But when you have resistors here making measurements, you want to make sure that they're kept at least in a stable lab environment, no greater than 1 degree plus or minus temperature change. And you want to make sure that they're free from oil and defects, and preferably even in a cage or some kind of metal box that you can shield, just to keep the EMI radiation away from the actual resistors themselves. You want to maintain that you have your proper guarding. Make sure that you definitely do not connect anything that has guard and ground together. This becomes a big problem, especially when you start working with things like 5700s or 5500s, which are more active devices or synthesized resistances. You have to be careful about making sure that you do not in any way connect their guards, which can be active, or their earth ground to the guard to the bridge, which can cause damage to either of the equipment. And lastly, when you're making all of these measurements, you want to, of course, make sure that you conform to the recommended test setups that exist within the bridge. In many cases, you can go faster and you can use the bridge at different parameters than what's specified, but when you run into problems, if you find you're not getting the results that you're expecting, the first thing you would want to do is take a look into the manual in the bridge and check what we recommend for the settings of the bridge, and make sure that you operate the measurements at that quality first before you start to diagnose any other issues, because some resistors are made better than others, and the reality is that poorer quality resistors do not respond as well under accelerated test conditions or in noisier environments than ones that are made at better quality. So you have to pay attention to all of these little details. So it's not so much just the instrumentation itself, but it's actually the device you're measuring and the environment in which you maintain it that you have to actually pay attention to as well when you're making these measurements. Essentially, that concludes our diagnosis and our troubleshooting guide for the 6625, and good luck with your measurements.